Okay, so we've used the video edge detection tools, the camera-based measurement tools for measuring features and scanning profiles, comparing to DXFs. Let's talk now a little bit about the CMM side of the machine. Standard Renishaw TP20 module is mounted there. I'm in the middle of building some probes for that. Beatty Fusion V4 software manages probes incredibly well. It makes it very easy for the user to build probe sets and new modules. I'm just going to add the final stylus to this particular probe set, and if I go up to my probe manager here, I'm just going to add the X Plus stylus. I've got a 2 by 20mm stylus mounted, so let's add that, and simply a case of making that the current stylus and then asking the software, asking the machine to go and datum itself. So the machine's now driving that stylus into the reference ball. The system obviously knows where the reference ball position is, and using that information we can not only calibrate and calculate the stylus tip diameter very accurately, we can also calibrate and calculate the tip position relative to the other tips and the camera. So having done this process now, I can select any of the tools in my probe library, and any dimensions that I make with any of those tools can all be related to each other because the offsets are known. So having calibrated all of the probe tips that I have assembled on this TP20 module, I can now use the little graphical icon that I've got here, which shows each of the tips that are assembled, and it's just a question of clicking on the tip that I want to use for the next measurement. I'm going to click on the Z down tip, that goes green, and now we can call for a plane measurement, and we're going to use touch probing to measure some of the features on this machined aluminium part. So let's move over, and I'm going to bring the touch probe in close proximity to the surface to measure this plane, and then using a joystick gesture there, I can ask the software to control that probe approach so that all of my probe measurements are taken under control speed and I'm not influencing that speed. So even as a manual measurement, I'm able to drive the probe using CNC control, like so. So let's take 4 points on a plane to describe the top surface of that component. We'll use that as a reference feature, and we're starting to draw the features in the X, Y and in the 3 views, just like we did with Vision. So now let's measure a circle. I'm going to call for a circle measurement form, drive the touch probe into the bore, and using the joystick control, I can ensure that probe points are taken at a controlled speed, so I'm not influencing the probing speed of this of these measurements. I'm just driving somewhere close and asking the machine to finish the job for me. So there's my diameter. We'll call that a reference feature for this template, and let's come out of there. And now I'm going to change tip, and we'll select the one of the X-axis tips and measure some features on this face. So next let's measure a line. I'm going to use a different tip to do this because I want to use a line on the side of this component, so I'm just going to use the graphic I referred to earlier. Let's click on the X-axis stylus and just drive down. I'm going to measure a line, so let's come somewhere close, call up for a line measurement, and again just flick the joystick towards the part, and the part is measured using controlled probing speed. So again, I'm not influencing that measurement. So that aligns the part, and now let's measure some other features on this side face. Let's call for a plane, And we'll first of all measure the plane around this bore. And now we can see some of the more three-dimensional views coming into play. So, as you can see, we've measured quite a few features now using various tips on the currently mounted TP20 module. The next thing I want to measure is the O-ring groove that's in the top of this housing. It's a very shallow groove, so I'm not going to be able to measure that with any touch probe. We don't have one small enough. Great example of why the Venture is such a great solution. We can just simply employ the camera now instead of having to take this part off the CMM and move it over to another measurement method. So let's put this probe away, because the length of the probe is such that it would actually foul on the part. So I'm just going to ask the software to put that away. And having done that, the software automatically gives me the camera as the active probe now, so I'm ready to go measure with the camera. So now let's measure this groove diameter and width using the camera. I've got an arc tool selected here, so I'm simply going to scan the edge there, having already organised the lighting to highlight that feature. So let's move around and adjust the lighting, and you can see the effect that the lighting has. There's a great edge there, so we'll use that lighting condition for this grab and move around the diameter. So having taken data grabs all the way around this groove diameter using the arc tool, different lighting conditions for each grab, all of that's getting automatically recorded into the program, in addition to all of the touch probe measurements that we did, making the finished article a combination of contact and non-contact measurements on the same inspection. All completely automated and couldn't be easier to use. Okay, so let's run the program. So the software knows that it has to first go and pick up the module, and we're going to use each of the tips that I selected to measure the various features.